Welcome to day 4, AMI. Today we'll talk about angles of rotation on the unit circle. So the first thing we need to talk about is, what is the unit circle? From now on, henceforth, forevermore, you need to know the unit circle is the circle centered at the origin, at the XY plane, with radius 1. That circle centered at the origin, the radius is 1. This is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. And this is the point 0, negative 1. All points on the circle. And of course there's an infinite number of points, all 1 unit from the center at the origin. We talk about angles of rotation on the unit circle. The question I always ask in class is, what is an angle? And most people think of an angle as something related to two rays or two lines intersecting. We are going to change the way we look at angles, and we're going to redefine as angles of rotation. You can look at it as a ray, and if we were to rotate that, where it starts, we call the initial side of the angle. And when we rotate in a counterclockwise direction, that ray would end. When we stop the rotation, we call that rotation the angle theta, and we call this the terminal side of the angle. And the rotation is now what we define as the angle. It's not a space between angles. It's not a gap between angles. It's the rotation from the initial side to the terminal side that determines the angle. When we rotate in that counterclockwise direction, we're creating a positive angle. We generally start with the initial side of our angles when we're talking about these in trig. If we're looking at the XY plane, the 0 angle is the positive x-axis. So if we were going to rotate 60 degrees, a 60-degree angle would start on the positive x-axis and rotate until we had formed a 60-degree angle on the circle. Circle's made up of 360 degrees, so 1/6 of a circle is 60 degrees. So we rotate 1/6 of the way around a circle, and that's the 60-degree angle. If we were going to rotate 180 degrees, when you take a geometry class, usually you're told the biggest angle you can have is 180 degrees. We start with a 0-degree angle. We rotate halfway around a circle. The entire circle is 360 degrees. So this rotation is 180 degrees. But now, since we've defined this angle as rotation, we start the positive x-axis and we rotate all the way around. We've rotated 360 degrees. So what's the largest angle we can make? Basically, we're asking, when does the rotation end? When does it stop? What's the biggest number we can rotate in degrees? If we start and we keep rotating in the positive direction, how many times can we go around before we have to stop? And the answer is, we can go as many times as we want. So the largest angle we can make, there is no largest angle. We can go to infinity. That's not the largest angle. but there is no largest angle. You want a 1,000,000-degree angle, rotate enough times around and you'll get there. There is no largest angle. We rotate in a counterclockwise direction to create positive angles. So if we rotate in a counter or a clockwise direction, start at that 0-degree angle, and we rotate clockwise direction to the negative y-axis. That's a rotation of a negative 90 degrees. Now, in geometry you were told you can't have negative angles, but now since we've redefined an angle as a rotation, we can rotate in a clockwise direction how many times before we have to stop? The answer is we don't have to stop, so there is no smallest angle. Angles can be anywhere from negative infinity to positive infinity. We talk about coterminal angles now. Coterminal angles are any angles whose terminal side is the same, stops at the same spot on the circle. If we look at the unit circle and we take the angle 30 degrees, that's starting at the 0-degree angle is our initial side, rotating 1/12 of the way around a circle, that's 30 degrees, but that terminal side stops in the same place as if we rotated complete revolution around a circle and then another 30 degrees. That terminal side would be at the exact same place, but this would be a 390-degree angle. Or if we were to rotate almost all the way around a circle in a clockwise direction to where this was 30 degrees between here and here if we rotated counterclockwise, but now we've rotated a negative 330 degrees. Negative 330 degrees, 390 degrees, 30 degrees, all of those angles are coterminal. They all share the same terminal side. How do we find coterminal angles? If you're given an angle measure, let's say 50 degrees. If we want to find a coterminal angle, we could simply add 360 degrees because 360 degrees is one full revolution around a circle. So, a 50-degree angle would be somewhere around here. So 50 degrees plus 360 degrees would be 410 degrees. So 410 degrees is coterminal with 50 degrees. To find coterminal angles, you can simply add multiples of 360. So for any angle n degrees plus or minus some number, integer k, value times 360. So 1 times 360, 0 times 360, 5 times 360, 12 times 360, 975 times 360, negative 10 times 360. Any number k here, integer value k here, that we did is coterminal with n degrees. We just add multiples of 360. an angle coterminal with 50 degrees. 10 times 360 is 3600, so 3600 plus 50 degrees. 3650 degrees is coterminal with 50 degrees. 5 times 360 degrees is 1800 degrees, so 1850 is also coterminal with 50 degrees. Questions you might see are: find a positive and negative angle coterminal with 725 degrees. There are many ways to do this, but I can look at it and I could say 725 degrees. I could add 360, but since I'm going down looking for negative angles too, I'm going to subtract 360 degrees. If 725 degrees and I subtract 360 degrees, I'm going negative angle rotation back to the same spot, one full revolution around the circle. So 365 degrees is a positive angle coterminal with 725 degrees. I subtracted 360. It's a positive angle coterminal with 725 degrees. If I continue to subtract 360, so I do 365 minus 360, that's 5 degrees. That's also coterminal, but it's still positive. So let's subtract another 360 degrees, and that's going to give me a negative 355 degree angle. So negative 355 is coterminal with 725. Here's another. If we find a positive and a negative angle coterminal with negative 3,751 degrees, we can add 360 degrees. Let me double check my subtraction here to make sure everything's right. That should be right. So negative 3,391 degrees is coterminal with negative 3,751 degrees. Now, I could add 360 a bunch of times before I finally got to where I want to be. I'm going to look at this and notice if I add 10 times 360, that's 3,600, and that's going to put me in positive range. So I'm going to subtract, I'm going to add 3,600 degrees to 3,391 degrees. You can do this with your calculator. I have done something wrong here. It's been too long. That's better. 209 degrees. 209 degrees minus 3,600 takes us to negative 3,391. Got a calculator, we can double check that. I could have just as easily added in a calculator. $209 degrees. So 209 degrees is also coterminal. With negative 3,751. Now we may also be asked to find an angle such that 0 is less than this angle theta is less than or equal to 360 degrees. We want that to be coterminal with 847 degrees. So since 847 degrees is larger than 360, I'm just going to subtract multiples of 360 until I get there. This looks like, if I subtract 360 degrees, I won't quite be there, so I'm going to subtract 2 times 360 degrees, or 720 degrees. And 127 degrees is between 0 and 360, so 127 degrees is coterminal with 847. And 0 is less than or equal to 127 is less than or equal to 360. So that's our lesson for day 4 of AMI.